Welcome to MSExamLab. This is PL-300 Power BI Data Analyst. Episode 5 Data Quality, Profiling and Errors. 13 Real Exam-Style Questions. Every answer key has been checked against Microsoft Learn before it reached this video. Where the question bank is wrong or its wording has been retired, I say so on screen. 13 questions. Profiling tools, error triage, cleaning dirty dimensions, nulls, and query structure that keeps the model small. Question 1 of 13, picking the profiling tool. You are using Power BI Desktop to profile data in Power Query Editor. You need to review the percentage of errors and the maximum value of each column. Which options should you use in Power Query Editor? 2 selections here. Review the percentage of errors. Choices are column distribution, column quality, monospaced, column profile, formula bar. Review the maximum value. Choices are column distribution, column quality, monospaced, column profile, formula bar. Pause here if you need longer, 10 seconds. The answers are column quality and column profile. Column quality reports valid, error, and empty as percentages. Column profile is the deeper pane. It carries a column statistics chart with count, distinct, unique, empty, min, and max. Those are 2 different tools for 2 different questions. Now, why the others fail? Column distribution gives you distinct and unique counts and a frequency chart, but no minimum or maximum. Monospaced only changes the preview font, and formula bar shows the M expression for the current step. One more thing, source error, the key says formula bar for the maximum value. The formula bar shows M code. Column statistics live in column profile. Verified against Learn Microsoft.com using the data profiling tools. Question 2 of 13, distribution of string lengths. You are creating a report in Power BI Desktop. You load a data extract that includes a free text field named call1. You need to analyze the frequency distribution of the string lengths in call1. The solution must not affect the size of the model. What should you do? Your options. A. In the report, add a DAX calculated column that calculates the length of call1. B. In the report, add a DAX measure that calculates the average length of call1. C. From Power Query Editor, add a column that calculates the length of call1. D. From Power Query Editor, change the distribution for the column profile to text length. Pause here if you need longer, 10 seconds. The answer is D. From Power Query Editor, change the distribution for the column profile to text length. The profiling pane is analysis, not data. Switching the column profile distribution to text length shows you the frequency of string lengths without adding anything to the model, which is exactly the size constraint the question sets. Now, why the others fail? A DAX calculated column materializes a value per row and grows the model. Adding a length column in Power Query also loads into the model and adds size. An average is a single number. It tells you nothing about the distribution. One more thing, must not affect the size of the model rules out every answer that creates a column. Verified against Learn Microsoft.com using the data profiling tools. Question 3 of 13, 2 errors, 2 levels. You use Power Query Editor to load 2 queries named Query 1 and Query 2. Query 1 results in Expression.Error. The column sales of the table wasn't found. Query 2 results in DataFormat.Error. We couldn't convert to number. Details. Know which type of error occurred for each query. 2 selections here. Query 1. Choices are cell level, OLAP cube, provider, step level, web view 2. Query 2. Choices are cell level, OLAP cube, provider, Step level. Web view 2. Pause here if you need longer, 10 seconds. The answers are step level and cell level. Query 1 is step level. The step cannot run because a column it names does not exist, so the whole query fails and no table appears. Query 2 is cell level. The query runs and one value, the text na, will not convert to number. Now why the others fail. A step-level error stops everything, which is why you see no preview rather than a table with error cells. Provider and OLAP cube errors come from the source system. WebView 2 is a desktop rendering component. One more thing, step level kills the query. Cell level leaves the table intact with error in single cells. Verified against Learn Microsoft.com dealing with errors in Power Query. Question 4 of 13, keeping every row. You have data in an Excel worksheet and need to use Power Query to clean and transform it. If the discount column returns an error, a discount of 0.05 must be used, all the rows of data must be maintained, and the solution must minimize administrative effort. What should you do? Your options. A. Select Replace Errors. B. Edit the query in the Query Errors group. C. Select Remove Errors. D. Select Keep Errors. Pause here if you need longer, 10 seconds. The answer is A. Select Replace Errors. Replace Errors swaps every error value for a value you supply, 0.05 here, and leaves the row count untouched. That satisfies both requirements in one step. Now why the others fail. Remove Errors deletes the offending rows, which breaks all the rows must be maintained. Keep Errors does the reverse and keeps only the bad rows. Editing in the Query Errors group is manual investigation, not a transformation. Verified against Learn Microsoft.com dealing with errors in Power Query replace values. Question 5 of 13, blanks under a heading. You use Power Query Editor to review a query with columns region, state, and Jan 24. Each region value appears only on the row where it first occurred. Every subsequent row for that region has a blank region value. You need to ensure that every row contains the correct non-blank value. The solution must minimize development effort. Which column should you select, and which action should you perform on it? 2 selections here. Column. Choices are Jan 24. Region. State. Action. Choices are fill down. Fill up. Replace the values. Unpivot the column. Pause here if you need longer, 10 seconds. The answers are region and fill down. This is the classic merge cell export. Region is the column with the gaps and fill down copies the last non-blank value downwards into them. One click, no formulas. Now why the others fail. Fill up would propagate the wrong region upwards into the previous group. Replace values needs you to know every value in advance and do it one at a time. Unpivot restructures columns into rows and does not fill anything. Verified against Learn Microsoft.com fill values in a column. Question 6 of 13, building a country dimension. You are creating a query to be used as a country dimension in a star schema. The source data contains both a country column and a city column. You need to create the dimension. The dimension must contain a list of unique countries. Which 2 actions should you perform? Each correct answer presents part of the solution. This one wants 2 answers, not 1. Your options. A. Delete the country column. B. Remove duplicates from the table. C. Remove duplicates from the city column. D. Delete the city column. E. Remove duplicates from the country column. Pause here if you need longer, 10 seconds. The answers are D, delete the city column, E, remove duplicates from the country column. Drop city first because while it is still there, every country repeats once per city and no two rows are identical. With only country left, removing duplicates yields one row per country. Now why the others fail. Removing duplicates from the whole table while city is present leaves every country repeated. Deleting country removes the very thing the dimension is for. Deduplicating city is the wrong grain entirely. One more thing, order matters. Reduce the columns to the grain you want, then dedupe. Verified against learn Microsoft.com remove duplicates star schema guidance. Question 7 of 13, dirty country names. You have a table named DIM countries that contains a column named country. The values arrive with inconsistent casing, for example, India, India, and India. You plan to use DIM countries as a dimension. You need to ensure that the country column lists each country only once. Which two actions should you perform on the country column? This one wants two answers, not one. Your options: A, change data category to country. B, remove duplicate values. C, apply a clean transform. D, replace the empty fields. E, apply a capitalize each word transform. Pause here if you need longer, 10 seconds. The answers are B, remove duplicate values, E, apply a capitalize each word transform. Remove duplicates compares exact strings so India and India survive as two countries. Normalize the casing first with capitalize each word, then dedupe, and you get one row per country. Now why the others fail. Data category only tells report visuals how to map a field, it changes no values. The clean transform strips non-printable characters, not casing differences. Replacing empty fields is a different data problem. One more thing, same lesson as the previous question from a different angle, normalize before you deduplicate. Verified against learn Microsoft.com text transforms in Power Query remove duplicates. Question 8 of 13, nulls in an average. You preview a query with the columns tax amount, sales order ID, freight amount, subtotal amount, and total item quantity. Sales order ID uniquely identifies each order. You need to calculate the average freight amount per order, counting orders with no freight charge as 0. What should you do? Your options: A, in the total item quantity column, replace the null values with 0. B, in the tax amount column, remove rows that contain null values. C, in the freight amount column, remove rows that contain null values. D, in the freight amount column, replace the null values with 0. Pause here if you need longer, 10 seconds. The answer is D, in the freight amount column, replace the null values with 0. An average ignores nulls, so orders with no freight would drop out of the denominator and the figure would come out too high. Replacing null with 0 keeps those orders in the calculation as genuine zeros. Now why the others fail. Removing rows with null freight deletes real orders and distorts the average the other way. Tax amount and total item quantity are not part of this calculation. Verified against learn Microsoft.com replace values working with nulls. Question 9 of 13, counting duplicate emails. You have a Power BI table named customer with a field named email address. Multiple records contain the same email address. You need a calculated column that identifies which records have duplicate email addresses. Count email equals customer email address equals email. Review the expression and the available values on screen. You drag from a pool of values into 3 boxes. The values are all calculate count ROWS evaluate sum SUMX. Pause here if you need longer, 10 seconds. The answers are Box 1, Calculate, Box 2, Count ROWS, Box 3, All. Calculate sets up the modified filter context. Count ROWS is the scalar expression being counted. All removes the row context so the count looks across the whole table rather than just the current row, and the final condition restricts it to rows sharing this email. Now why the others fail. Sum and SUMX aggregate a column of values. Here you are counting rows. Evaluate is a query statement, not something you use inside a measure or calculated column. Without all, the calculated column would only ever see its own row and always return 1. Verified against learn Microsoft.com calculate count ROWS all functions. Question 10 of 13, splitting one query into two. In Power Query Editor, you have a query named Sales Data. You need to create two queries named Product Dimension and Sales Fact based on the Sales Data query. The solution must minimize maintenance effort and the size of the dataset. Which two actions should you perform? This one wants two answers, not one. Your options. A. Reference the Sales Data query to create the new queries. B. Disable the load for the Sales Fact query. C. Duplicate the Sales Data query to create the new queries. D. Clear include and report refresh for the Sales Data query. E. Disable the load for the Sales Data query. Pause here if you need longer, 10 seconds. The answers are A. Reference the Sales Data query to create the new queries. E. Disable the load for the Sales Data query. Reference points both new queries at the single Sales Data query, so a change to the source logic is made once. Then disable load on Sales Data itself because it is only staging and nothing should report on it. 2 dimensions of waste removed. Now why the others fail. Duplicate copies every applied step into both new queries, so any future fix has to be made twice. Disabling load on Sales Fact would remove the fact table you actually need. Clearing include and report refresh stops the staging query refreshing, which breaks the two queries built on it. Verified against learn Microsoft.com reference versus duplicate queries enable load. Question 11 of 13, 1 query 3 consumers. You have a Power BI semantic model with 4 queries. Query 1 loads customer data and is referenced by the other 3 queries. Data refresh for the model is slow. You need to improve the refresh time. What should you do? Your options. A. Run the table, buffer function in query 1. B. Duplicate query 1 to all the other queries. C. Reconfigure query 1 as a data flow entity. D. From the Power BI admin portal, increase the capacity settings. Pause here if you need longer, 10 seconds. The answer is C. Reconfigure query 1 as a data flow entity. A referenced query is reevaluated once per consumer, so query 1 source is being hit 3 times on every refresh. Moving it to a data flow makes it load once on its own schedule and the 3 queries then read the stored result. Now why the others fail. Table buffer caches within a single evaluation. It does not stop the other 3 evaluations happening. Duplicating query 1 makes the problem worse and multiplies the maintenance. More capacity throws hardware at a design problem. Verified against learn Microsoft.com data flows best practices query evaluation and caching. Question 12 of 13, hitting the memory ceiling. You have a Power BI report. For the last 3 days refresh has failed with, you have reached the maximum allowable memory allocation for your tier. Consider upgrading to a tier with more available memory. The invoice table holds many years of transaction-level history. What should you do? Your options. A. Merge the salesperson and invoice tables based on the salesperson ID column. B. Change the invoice table to a direct query table and read the data live from the source. C. Reduce the size of the invoice table by summarizing sales by product, sales person, and date. D. Change the invoice table to a composite table that contains historical data as direct query and recent data as import. Pause here if you need longer, 10 seconds. The answer is D. Change the invoice table to a composite table that contains historical data as direct query and recent data as import. A composite design keeps recent data imported for fast interaction while the long historical tail stays in direct query and never occupies model memory. That resolves the ceiling without discarding detail or slowing everything down. Now, why the others fail. Summarizing away transaction detail loses the granularity the report may need. Making the whole table direct query fixes memory but makes every visual slow. Merging tables adds columns and increases the model size. Verified against Learn Microsoft.com composite models data reduction techniques. Question 13 of 13, a column that vanished. You use Power BI Desktop to open a PBIX file that contains an Excel data source. You attempt to refresh the data and receive Expression.Error. The column cost of the table wasn't found. What is a possible cause of the error? Your options. A. The cost column was renamed in the data source. B. The privacy level of the data source does not allow combining the data with other data. C. The data in the cost column cannot be converted into the target data type. D. The source file was moved to a new location. Pause here if you need longer, 10 seconds. The answer is A. The cost column was renamed in the data source. Power Query hardcodes column names into every step. Rename cost upstream and each step that names it breaks. Expression.Error tells you the source was reachable but a step referred to something that is not there. Now, why the others fail. A privacy level block raises a formula firewall error and names the firewall. A failed conversion gives DataFormat.Error and talks about a value, not a missing column. A moved file gives Datasource.Error, different prefix, different layer. One more thing, third time this episode, read the prefix before you read the message. Verified against Learn Microsoft.com dealing with errors in Power Query. 6 things to carry into the exam. 1. Quality distribution profile. Quality gives percentages, distribution gives distinct and unique, profile gives statistics. 2. Read the error prefix. Expression.Error is a broken step. DataFormat.Error is a bad value in one cell. 3. Replace, don't remove. If all rows must be maintained, replace errors. Remove errors deletes rows. 4. Clean before you dedupe. Capitalize or trim first, or India and India survive as 2 countries. 5. Reference, don't duplicate. Reference reuses one query, duplicate copies the steps and doubles the maintenance. 6. Disable load on staging queries. A query nobody reports on should not land in the model. That is episode 5. Episode 6 is star schema and relationships, fact and dimension design, cardinality, cross-filter direction, and the many-to-many problem. This series runs 20 episodes and covers the whole exam. Subscribe so you get each one as it lands. And tell me in the comments which question caught you out. I read them all. See you in episode 6.